basic C tutorial series. And just to start with, imagine you have a light bulb. And this light bulb has two states. You can obviously either be off or on. So, off or on. Let's go ahead and make this bigger. So, you know, it's pretty often you hear computers break things down into binary ones and zeros, but if you think of a single light bulb, off or on, that's not a lot of information. It's actually the smallest possible amount of information, so it's often called a bit. A bit is a single one or zero, off or on. It's not very useful, and again, like I said, it's the least useful amount of information. It's a single bit of information. So our one light bulb isn't going to help us a lot at all. But what happens if we have two light bulbs? Well, if we have two light bulbs, then we have, all of a sudden, we go from two states, on and, or, on and off. We go to four states with two light bulbs. We can have off, 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 on, off, and on. So, we're making our way up the chain. So, one light bulb, two states. Two light bulbs, we have four states. Now, what happens if we have three light bulbs? We have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So we go to a massive 8 states already with just a third light bulb. So let's go back here. Let's draw some pretty primitive light bulbs. So this is one bulb. So this is with two bulbs, and this is with three bulbs. So with one bulb we have two states. Two bulbs we all have four states, and with three bulbs, lights, LEDs, whatever, all of a sudden we have 8 states, and we can actually continue the trend, which you've probably picked up on. So we have 4 lights we can turn on and off. Then we have 16 states. If we add another bit, that's 32 states. If I could write it, add another bit. So this is 4 bits, 5 bits, 6 bits, we have 64 states, and 7 bits, we have 128 states, and with 8 bits, we have 256 different states. And so the states, specifically, since we start with 0, 0, 0 for all of them, like imagine if we have 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8, and all the light bulbs are off, or all the bits are off, or whatever. Then we start with 0. I can't write on that. So we have 0. And then you can kind of continue up the pattern. So if we go, it works exactly the same the other way. So 1, 2, 3, 4, 5, 6, 7 bits off. Next one on. What did I hit? 0, 0, 0, 0, 0, 1, 0. And you can kind of go all the way up. 1, 1, 1, 1. So if we just go in line, if we were counting all the different possible combinations of the bits as we go, this would be 1, 2, dot, 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 and we would go up to 255. So 8 bits actually has a special name. It's called a byte. In most parts of the world. In weird places like France, this is called an octet. But since we're in the American version, we're going to call this a byte. So 8 bits is called a byte, and a byte basically just means that it's a number from 0 to 255. It's the easiest way to think about it. But if you think about it, or as you get more and more used to it, it's 8 bits. Those bits can be on and off for a certain state, and there's a really easy way to actually remember what number bit will be. So if we go 0, 2, 3, 4, 1, 2, 3, 4. If you remember the counting that we did, um, let's see here. Well, 1, 2, 4, 8. Nah, exactly. It doesn't actually work that way. If you look here, the bit here will always be 1, 2, 4, 8, 16, 32, 64, 128. So if the bit is set, so if we have a number like, if we have a combination like 0, 1, 1, 0, 1, 1, 1, 0, to make things complicated for myself, we can just look up the bits. So the 2-bit set, 4-bit set, 8-bit set. So 2 plus 4 plus 8. 32 is not set. Wait, so 1, 2, 4, 8, 16, 32, 64. So plus 32 plus 64. Let's see, 40. Let's see. Is that gonna be 100? Wait, 40. I think it's gonna be 110. This comes to 68, 70. So 70 plus 40. This is 110 in binary. So you just look at the bits, which bit is set, and you add them up. So it's actually kind of simple. If you can do basic arithmetic, then you can do binary. And it's just a matter of understanding if it's just on and off, 1 or 0. So this is 1 bit or 1 byte, and we can express a number between 0 and 255. So come back here. So if we have 16, then it kind of starts getting crazy. We can go from 0 to 65,000 bits. So 65,000. What's the number? 535. I'm definitely not looking this up. And then if we have 32 bits, we can go from 0 to, it's some stupidly big number. It's like 4 billion. 4.29 billion is the range of numbers that can be expressed between with that number of bits. So in the C programming language, we actually have a special number for these. 8 bits is a character. 16 bits is a short, and 32 bits is an int. So if you see these data types, char, int, short, and it says storage size and value ranges, it's kind of generally hard for beginners to understand why these data types have these specific properties, because it seems very, very arbitrary. 0 to 255, what 0 to 6,535? It seems very arbitrary, but the reason for it is actually pretty simple and self-explanatory. If you have a light bulb or something that's either on and off, it's not very useful. But you can line up multiple versions of, or you can line up multiple light bulbs or multiple on and off thingies. Scientific word there. Silicon, or I can't actually remember the word that I'm looking for, but registers? No, it's not registers. Whatever. There's a word I'm looking for and I can't find it. But if you line up 8 of these, ones and zeros, then you have a byte, and you can express the values between 0 and 255. If you have 16 ones and zeros, you can express values between 0 and 65,000. 32 bits, 0 and 4.29 billion. And if you're wondering about, oh wait, how do you do negative numbers? Well, with negative numbers, we have something that's called signed and unsigned. So for the most part, positive. But if we have a signed character, then that means that this byte on the end here is not positive 128. It's actually minus 128. And so the effect of that is if you have minus 128, if you have 1, 0, 0, 0, 0, 0, 0, 0, 1 followed by 7 zeros, you have 100 minus 28. If you have 1, 1, 1, 1, 1, 1, 1, 1, then these 7 ones will add up to positive 127, and this 1 will be minus 128, and that's how you express negative 1. And so the easiest way to think about it is rather than this being a positive 128, it's a negative 128, and these bits on the side will add up to a number and cancel out from here, and that's how you can express negative numbers using binary. So basically, all computers do is they just stack up ones and zeros of these little light bulbs on top of each other to different lengths to express them as you need, and it's not really important to understand how these characteristics influence your programs just yet or what they're used for. But it is important to kind of understand early, to kind of get a concept early on of these numbers aren't some arbitrary number that just someone randomly made up and just because they felt like it. There's actually a physical reason behind these numbers being like that, and the sooner you kind of learn the reason for that, the less pain you'll experience later on. So this was the second tutorial-ish, just kind of explaining why the reasons for the types, and that's it. I'll see you in the next tutorial. See you next time.